Lab. Today we're going to go ahead and introduce assembly files in SolidWorks. So you've got really good at making parts in SolidWorks. Today we're going to start talking about how we can take those individual parts and put them together into a mechanism or an assembly file and tell SolidWorks how those different parts relate to one another. But first, there's two remaining tools in the sketcher that we want to talk about. Because we haven't covered them yet, but they are very important and very useful tools. One of them is called Sketch Picture. The other tool is called Sketch Block. Now, the Sketch Picture tool allows you to take a photograph or any other image file and actually import that image into a SolidWorks sketch so that you could just trace over it. Okay, so for example, if you were going to create a SolidWorks model of something like this mouse, some oddly shaped object, it would probably be easiest to just take photographs of this mouse from above, from the sides, from the front and the back, bring those photographs in on different sketch planes, and then just sketch some splines over the edges of the picture and produce a wireframe model that then you could use surfacing to produce the SolidWorks model. And for an oddly shaped object like this, that would probably be a lot easier, just tracing over a picture, than it would be to take a ruler and try to measure dimensions on this object and try to use just dimensional information to reproduce this shape. Right? So I'll show you how to use Sketch Picture in just a second. The other tool that we're talking about is Sketch Block. That allows you to take a sketch that you've created and save it in its own independent file. And you can then reuse that sketch block in your part over and over, or in different parts over and over. So this could be useful if, for example, you're working for a company, or maybe you own your own company, and you created a company logo in a sketch, and you want to put that logo into every part that you manufacture. Well, you could just save that sketch as a sketch block, and then you can bring it into all of your different parts very easily. And what's nice about sketch blocks is each time you insert a sketch block, SolidWorks lets you scale the sketch block, make it larger or smaller, and you can also specify an angle of rotation for that sketch block if you need to change its orientation. So to demonstrate those two tools, I'm going to use this airfoil as an example. So this is NACA 4415 airfoil. Now, when I tell you this is an airfoil and show you a picture of it, what is that actually? Because some people may not be familiar with what an airfoil is. So what is this?
Cross-section of the airfoils.
Okay, it's a cross-section of the wing. Of the wing, exactly. This is an airplane wing. Okay, so the airplane is facing this way. The wing extends into and out of the screen lengthwise. We've sliced through the wing, and this is the cross-sectional shape of that airplane wing. Okay, so as the airplane is flying along this way, the airflow comes in, it passes over and under the wing, and that's what generates lift upward. There's a lot of different airfoils that have been standardized and defined. NACA 4415 is just one particular one, but there's many other airfoils that have different shapes. And they've been studied extensively in wind tunnel testing so that we know the aerodynamic performance of these different airfoils. So suppose that you've decided this is the airfoil shape that you want in your part. This has the aerodynamic characteristics that you need. You want to reproduce this shape in your SolidWorks model. The easiest way to do that would be to bring this in using the Sketch Picture tool and then just trace over it with a couple of splines. So, in SolidWorks, go ahead and start a new part. And I will start a new sketch. Doesn't matter what plane, I'll just pick the front plane. Okay, so to bring the picture in, you're going to go to the Tools menu, go to Sketch Tools, and then go down to Sketch Picture. So that's a command sequence you might want to write down, because that's easy to forget. Go to the Tools, Sketch Tools, Sketch Picture. Tools, Sketch Picture. Click that button, and then that lets you browse to find the image file you want. So here's that PNG PNG file. You can also bring in a bitmap or a JPEG or any other image file. So it brings that picture into your sketch. Now, one thing that I'll point out, just in case it's useful in certain circumstances, you can set the entire picture or portions of the picture to be transparent if you want. Like you could set the full image to be transparent if you wanted, if it was covering up something that you wanted to see, or you could make it partially transparent. Or, like if you just wanted to take this white background color and make that transparent, you can do a user-defined, select that white color and make that fully transparent or partially transparent, whatever you want to do. I'm not concerned about transparency right now. What I am concerned about is the size of this picture. Now, it comes in, any picture you bring in is going to come in at some random size. That depends on how many pixels are in the picture, how large it was when it was saved. You don't really know how big a picture is going to come into your SolidWorks part. And there's nothing that you can smart dimension on the picture because it's just a bunch of pixels. There's no sketch elements in this yet. So, what I would recommend you always do when you bring in a picture and you want to trace over it is go ahead and create for yourself a reference line using a center line with some known length. So I'm going to start a center line and just draw it horizontally and smart dimension that center line to be 1 inch. And then, so you can see the picture is much larger than that, but then I can double click the picture and I can just drag the corner to scale it down and make it about that size. So what I want to do, because I'm going to use this to create a sketch block, and as I mentioned earlier, we can scale a sketch block whenever we insert it, make it larger or smaller. So it's convenient to have this some unit length, like 1 inch. Because then if I want a 6-inch airfoil, I just multiply it by a scaling factor of 6. So you can just drag the picture to position it and to adjust its size until it matches up with the center line that you've created. And I'll just say that's good enough. Now, to make any kind of an airfoil shape, I would always recommend that you use a 3-point spline for the top and a 3-point spline on the bottom. Okay? And so I'm just going to start a spline. I'm going to click once at the trailing edge, then click at this highest point of the airfoil where it kind of flattens out there at the top. I'm going to put 1 point there, and then put the 3rd point right up here at the leading edge of the airfoil. Hit escape. That's my first spline. And then I'm going to start a new spline, and again, go from the trailing edge to the lowest part of the airfoil where it kind of flattens out there. And then connect back up to the leading edge of the airfoil, and that's my second spline. Now, manipulating these spline handles, where this airfoil flattened out on top, I want that spline handle to be horizontal. So I just make that constraint, and up here at the leading edge, I want that handle to be vertical. Vertical, there we go. And then for the lower spline, same thing. Where it flattens out at the bottom, I want that handle to be horizontal. And up at the leading edge, I want that handle to be vertical. And then, just by adjusting the angle and the magnitude of these remaining handles, you should be able to get a shape that very closely approximates the shape of that airfoil. And it takes just a little bit of playing around with it. With just a little bit of trial and error, you can get a shape that very closely approximates the shape of that airfoil. So let's say I've played with that long enough, I'm happy with the shape, that I've matched the picture close enough. What I want to do now is save this shape into a sketch block. So this is another command sequence that you'll want to write down. To create a sketch block, you go to the Tools menu, go down to Blocks, and then click Make. Tools, Blocks, Make will bring up this selection box where you choose what you want to put into the sketch block. So I'm just going to click the 2 splines. And you have the option of choosing an insertion point down here. The insertion point is optional, but it's a good idea. Okay, the insertion point is the point on the sketch that will follow your cursor around whenever you insert this into your new part. So, like if I want to make sure, if I know that I'm going to put this airfoil someplace and I want to snap the leading edge to a particular location, maybe at the origin or something, I would want to drag this insertion point right up there to the origin and just snap it, or right up to the leading edge. I mean, just place the insertion point there, and go ahead and click the check mark. Okay, so that created the sketch block, and you see it now listed over here as block 1-1. And I will accept that sketch. Now, if the picture is in your way and you want to hide it, over here in the sketch 1, you've got the sketch picture 1, that's your picture. You can just right click on it and suppress it if you want that to go away, and then you're just left with the sketch itself. Now, if you want to save that sketch block to a disk, over here in the feature manager, just right click on it and say save block. And then you can choose a location. I'll just put it on the desktop, call it block1.sldblk, save that. Okay, and back on the desktop, here's the solid block part that I just created, or the sketch block. It's not a part. Okay, so back in SolidWorks, I've got my sketch block saved. I'm just going to go ahead and delete that file and start a brand new part to show you now how we can bring that sketch block in and do something with it in a new part. So I'm going to say start a new sketch on the right data plane. Now to bring the sketch block in, we go to Tools, Blocks, and Insert. Click Tools, Blocks, Insert, and then browse to find the block that you want. It's on the desktop, and I should be able to find block 1 right there. Say Open. And it follows my cursor around. Notice it's the insertion point that's following my cursor around. And if I want to snap that to the origin, I can easily just place that right there. Notice over here, this is where you can set a scaling factor if you want to make it larger or smaller, and a rotation angle. But I'll just click that one there and hit escape because I don't want a second one and accept that sketch. Okay, so there I placed the sketch block. Let's do one more. Let me create a reference plane that's offset from the right data plane, say 10 inches. And let me place that sketch block again on that plane, but we'll scale it this time. So I start a new sketch on that plane, do normal to it, and then go to Tools, Blocks, Insert. My block 1 is selected. This time let's go ahead and just scale it down. Let's make this one say 0.5, and maybe even let's rotate. Let's give it like a 10-degree angle of incidence, and we'll just stick it right about there. Okay, and accept that. And we could dimension to that leading edge if I had a precise dimension that I wanted to locate that at. So anyway, there's the two blocks that I placed. That's how easy it is to reuse sketch blocks, and you don't have to recreate these sketches over and over. Okay, so do you have any questions about creating or using sketch blocks or the sketch picture tool? Anything that we've seen so far? Pretty straightforward once you know where those commands are located, but they really can make your work a lot easier, save you a lot of time. Okay, so let's get rid of that and start talking now about assemblies. So the first assembly that we're going to make this week is the Mars rover Curiosity, or based on the Mars rover Curiosity. I've given you all of the parts you need to create this assembly on D2L. So on D2L, we go to the content area of this course. For this week's lab, there's the Space Rover module, and you can click the Space Rover parts and download that. And I'm just going to save that to the desktop, spaceroverparts.zip. Completed. Nice that. Okay, so here is the Space Rover parts zip file that I just created, or just downloaded. Just out out of curiosity, how many of you have worked with zip files before? Okay, about half of you. What is a zip file? Okay, it's a compressed file, and so it takes files and makes the file size smaller, but it also does one other important thing, and that is allow you to take multiple different files and put them into one file archive, one file name. So, for example, if I double click on this zip file that I just downloaded, you'll see it expands and there's 5 different part files in that one zip file. So the zip file is just a convenient way. Not only does it make the file size smaller, which, let's see if I can show all of this. Okay, so here's the original file size, here's the compressed size, and you can see the compression ratio there. It's making these about half as big as the original parts were by compressing them. But this also saves you from downloading 5 different part files from D2L. You only have to download one zip file. The important thing with a zip file, though, is you do not want to work directly with the compressed versions of the files. When you download the zip file, the first thing you want to do is uncompress it. So right-click on that zip file and use this Extract All option. And you can choose a location. I'll just put it on the desktop. Let's just say Extract. And SOLIDWORKS goes through and uncompresses those files, and now gives me this space over parts file folder. If I double click on that, now we have the normal uncompressed versions of those files. And these are the ones that you actually want to work with. Now, I think if I go back to this zip folder and double click on it, SOLIDWORKS will actually try to open a compressed version of a file. So if these are the zip files. If I double click on this rover body solid part, okay, it gives me, this is good, at least it gives me a warning message. It says it's not available for write access. Now, if I click open it as read only, okay, it does go ahead and open it, but if you can see the file name up here, it tells you that it's read only. Even though it opened this file, do not work with the compressed versions of the files, okay? It causes all kinds of problems. Compressing the file is a little bit like encrypting it, because you're actually changing the bits of data, and that causes all kinds of problems for SOLIDWORKS. So, the important point to make here is don't work with the zipped versions of the files. In fact, after you extract the files, I would encourage you just go ahead and take that zip file and delete it. Get rid of it, that way you don't accidentally pull a part out of it and mess up your whole assembly. Okay, so I've got the uncompressed versions of the files there, and in SOLIDWORKS we're ready now to start a new assembly. So we go to File, New, and for the first time we're going to choose an assembly document. Say OK. And SOLIDWORKS opens up ready for you to bring the first component into your assembly. So you just browse for it. I'll find that folder with my parts, space over parts. Now, you want to put a little bit of thought into which component you bring in first, because that first component is kind of going to be the foundation of your assembly. All the other parts are going to be defined relative to that first component that you bring in. So for our rover part, what makes sense to be the first component we bring in? The body. This is kind of the center of the whole assembly, so let's bring that in first. So I'll choose rover body, click open, and that's just following my cursor around now. Wherever I click, it's going to drop that part into the assembly, and there we go. It's just kind of fixed in space wherever I click. Now, notice in the model tree, your assembly file does have an assembly front plane, top plane, right plane, and an origin. And just like part files did, and now we've got this rover body solid part, which you can expand, and you can see all the features of this part file. It's front plane, top plane, right plane, origin, and then you can see the individual features that made this part. You can expand those and see the individual sketches that were used to define those features. So we're just kind of nesting the parts inside this assembly file, and you still have all the part and sketches, all the features and sketches nested inside the part file.
Now, rather than have this at some random location relative to the assembly reference datums, it's probably a good idea to go ahead and put this in a more logical position. So in assemblies, the way we tell SolidWorks where something belongs or how it relates to the rest of the assembly is to use this Make button. Okay. Now right now, the body is just fixed wherever I clicked it. So to unfix it, I can right click and choose this command that says float, and now it's free. I can drag it anywhere I want. And now I can use the Make button to precisely position it relative to our assembly reference data. So when I click the Make button, this dialog box opens up. I'm simply going to click some feature on the component. It could be a face, a point, an axis, a data plane, anything on the component, and click something on the assembly model and tell SolidWorks how those two entities relate to one another. So for example, I want to choose this top face of the rover body and choose the top data plane of the assembly file and tell SolidWorks that those should be coincident. Okay? And then I click the green check mark to accept that constraint for that mate. And as a convenience, this box stays open so that I can just keep specifying additional mates. Because that really is the main operation you're doing in assemblies. You're just specifying one mate after another to relate these components to one another. But notice the different kinds of mates that you can make. You can make things coincident. You can make faces or planes parallel to one another, perpendicular, tangent, concentric. Concentric just means that two curved entities will have the same center point or the same axis. There's an option called lock. I would recommend that you never use the lock constraint, because that causes more problems than anything else. Avoid using the lock constraint. But you can also specify an offset distance or an offset angle. Those are very useful. Okay, so we've made it the top surface to the top data plane of our assembly. Let's go ahead and make the front surface of the body to the front data plane of the assembly. Make those coincident. And set that. And then also, I want to take the mid-plane of this rover body, which, let's see, top view. In the rover body, there was a, let me expand this, plane 1 was created for you as a convenience to be the mid-plane of this rover body. So I can take this plane 1 and made it to the right data plane of the assembly, make those coincident. So now my rover body is fixed in a logical location relative to the assembly references. And if I go to like a front view, that gives me a logical front view, a right view, and a top view. All give me views that make sense for this rover body. And now I'm ready to just start assembling additional components to the body. So to bring in more components, we click the Insert Component button. We browse to find the components we want. You can select multiple components at once by holding down the Control key. So I'll hold down Control and click Arm 1, Arm 2, and Part 2. Those are the three components I want to bring in. Click Open. And then as I click the mouse around here, it just places each one of those components sequentially. There's Arm 1, Arm 2, and Part 2. Okay, so they're just floating in space, but now I can specify how these components relate to the rover body. So I will turn on temporary axes so I can see the axes in each of these. Let's drag this down a little bit closer to where it belongs. So what I want to do first is put this arm onto this little knob that's sticking out from the rover body. So just go to Mates, and I can choose that axis and that axis in the little peg and make those coincident. Click accept the check mark. Okay, so those axes now are going to be coincident. And if I click and drag this, I can still change its rotation and I can slide it back and forth, but I can't misalign those two axes. Those are always going to be coincident. So the other thing I want to do is make this face here coincident with the corresponding face, circular face of that knob. part of the arm inside the rover body, and it made those faces align facing the same direction. I actually wanted them to be mated facing the opposite directions. So to change the mate alignment, I still want them to be coincident, but I can change the mate alignment with these two options right down here. Just click the, SOLIDWORKS calls that anti-aligned. Okay, but that just flips it around. And SOLIDWORKS tells me it changed the alignment. Yeah, that's what I asked for. Okay, so now we can rotate that down. Like that. So now this arm is still free to rotate up and down, but I can't mess up its position. It's right where I want it to be. Okay, so let's bring in this next arm, arm 2, and I want to put this arm right down here connected to this end of the first arm. I could do it the same way by aligning the axis and then the face, or a little bit of a shortcut is I can accomplish that same thing by simply making that circular edge coincident with the corresponding edge of the arm 1. Take that edge, okay, that brings it down into position. Those are aligned correctly. Okay, so now this arm is also free to rotate, but it's going to stay attached to arm 1. Now let's do the same thing with this arm. I'll take that lower circular edge, made it to that lower circular edge of that receptacle. Okay, and it's free to pivot. Okay, so what I want now is 2 more copies of that arm. So how could I get 2 more copies of this arm?
Insert the same part.
Very good. I could go back to the insert component button and just bring it in just like I did the first time. Here's another shortcut. If you, I close out of the make box, if you hold down Control and click and drag a component, that will duplicate that component. Okay, so just hold down Control, click and drag, that makes another copy of the component. So you can very quickly bring in additional copies of the component just by holding down Control and clicking and drag. Okay. So we'll make those 2 the same way. I want that circular edge to be mated with that circular edge of that arm, and that edge made with that edge, and accept that. Now, the next component we want to bring in is the wheel. So I'll go back to Insert Components and browse to find the rover wheel, and I'll just drop that someplace in the assembly. And let's make this surface of the wheel with the corresponding surface of that arm. Now those are lined up. Let's make the central axis of the wheel. The central axis of the wheel with corresponding axis of the hub. And then finally, we need to line up the bolt holes so that they're not offset like that. So we'll just make an axis of that hole with the corresponding axis in one of the holes. Like that. Okay, so the wheel is in place now. We want 2 more copies of the wheel. So what's the way we just saw to get duplicate copies of a part? Control, click, and drag. Okay, but here's another even faster shortcut. Since the mates of the new wheels are going to be very similar to the mates that I just created on this wheel, we can go up to the Insert Components button and choose Copy with Mates. This allows you to copy a component and essentially reuse the same mates, but apply them to different locations on the assembly. So, Copy with Mates. First, I'm going to choose the component I want to make, and that is the rover wheel. And the mates that I used for the first rover wheel are already listed here. So here's mating those 2, mating that hub surface, and then mating the central axes, and mating the axis and the bolt holes. Okay. So those mates are already halfway defined. SolidWorks is just waiting for me to click on new references in the assembly to put the new copy of the wheel onto. So for that first reference, I'll just click on that flat surface of the hub. Then I'll click on the central axis, and then click on one of the lug nut axis holes. And with those 3 clicks, I've created a copy of the wheel and placed it properly into the model. Okay. To do the third one, I just click the check mark and repeat that process. Just click on that surface, that central axis, and then the axis of the hole, and accept that. So this is really, copy makes it really useful when you got like 50 screws that you have to put into an assembly. You can see how quickly we just did the 3 wheels. You can put a lot of components into your assembly very quickly using copy with make. So that's a very handy shortcut. Okay, so we got half of the rover wheel arm assembly done. What do you suppose exists for doing the other half? Mirrors, right. So there is a mirror command. In the assembly, it's just a little bit more complicated than it was in the parts. But if we go to the linear component drop down, this is where you can find the command that says mirror components. So click mirror components, choose the mirror plane. Remember I had that plane 1 defined as the mid plane in the rover body. So I'll just find that in the model tree. Choose plane 1 as the mirror plane. And then choose the components to mirror. I'm going to click around all these. I want that arm, that arm, that arm, that one, and then each of the 3 wheels. So I've got all the components selected. Now I need to click this little next button. That gives me a preview of the mirrored components, but notice some of them are backwards. Like this first arm 1, which is highlighted in purple, is actually backwards. This curved end should point towards the body, not away from it. And this arm 2, this one's actually upside down, because it should bend downward. So when you get the preview of your mirrored components, you want to look at those components and see if they're mirrored correctly. And if not, you can select any component that's not mirrored correctly. And down here you can choose, essentially you're choosing what quadrant to mirror it about. So you've got 4 options. As I scroll through these options, you'll see it just reorients the arm 1 into different configurations. Now, a situation like we're doing, where we're actually taking parts and just moving it to the opposite side of an assembly, is very common. So SolidWorks gives you a shortcut button for that situation that says create opposite hand version. That's what we're doing here. We're just taking this right hand version and creating a left hand version from it. So in this case, rather than scrolling through and finding the configuration that looks right, I can simply click this button that says create opposite hand version, and it knows what it should do. Okay, it gives me the correct mirror component. We want to do the same thing with arm 2 here, because that one's backwards. So select arm 2 and say create opposite hand version. That flips over to be correct. I believe all the other components mirrored correctly. Okay, so the preview looks correct, and we're ready to go to the next step. Did you have a question?
I was just going to wonder why some parts are blue.
What, these parts are blue?
No, the other side. Yeah.
Okay, the purple, okay, yeah, that's just whatever part I have selected is going to be highlighted. Okay, so once you get the correct orientation of each of your mirrored components, then you want to go to the next step of the mirror command. And it tells you you've created opposite hand versions of arm 1 and arm 2. And SolidWorks needs to create new copies of those files because of that. Okay? When you create an opposite hand version, SolidWorks actually wants to duplicate that part file and invert all the geometry and then save that as a new part file. That's how it's going to get the arms for this side of the assembly. Well, that's fine. We just have to tell SolidWorks, okay, create new files, It's going to add the prefix mirror to the original part names for these parts that it's created. So that's all fine. We can just click the check mark and SolidWorks does its job, and we end up with the mirror components just like we want. Let's turn off these temporary axes because they're just getting a little bit cluttered. Okay, and one thing that's nice when you mirror components is you do have a connection, like these components are slave to one another, so if you do something on one side, it will duplicate that motion on the other side, which is handy sometimes. Sometimes it's not. Anyway, let's see. Okay, one other thing that you're asked to do in the homework is to make the rover body transparent. So there's a quick and dirty way to do that. If you just right-click on the rover body, and there's a shortcut button that says Change Transparency, you can click that, and that makes it, by default, I think 75% transparent. But do you remember a few weeks ago, we showed you another way to make components transparent? Okay, we right-click and choose the Edit Appearances button, the little beach ball looking icon. Choose what we want to change the appearance of. In this case, it's the rover body part in the assembly. So I'll click that. And then, remember, this is where we set the color when we were making things orange. And if we go to the Advanced tab and go to the Illumination tab, then we have the transparency amount out here. And we can set that to whatever value we'd like it to be. So a couple different ways you can make something transparent. Okay, so any questions about anything I've done here, putting this rover together? What questions? Okay. So what I should do now is save this. I should have saved it a long time ago. But I'm going to go ahead and click the Save button. And SolidWorks says it needs to rebuild the assembly. That's fine. It just says it wants to go through and regenerate all the parts and make sure everything is up to date. So if you ever get this message about rebuilding, just say rebuild it. SolidWorks lets me put in a name. I'm going to save it to the desktop and just call it My Rover. Click Save. Okay, now what I have just created on the desktop is this file right here called myrover.sldasm. The most important thing that you need to learn in today's lesson is how to properly save your files, your assemblies, so that you can take them to another computer or so that you can submit them for your homework. This file that I just created is, like I wrote up here on the board, this file is nothing more than it's nothing more than a file containing instructions on how to put those parts together. But if I take this SLDASM file to another computer and try to open it, SolidWorks is going to look for every one of these component part files, and if it cannot find these part files, it cannot open the assembly. Because the part information is not contained in the assembly. The assembly is just a set of instructions that tell SolidWorks how to put the parts together. So, if you were to submit this one file for your homework, we wouldn't have anything that we can actually create because we can't open the assembly. What you need to do is submit not just the assembly file, but all of the parts you built the assembly from. Now, because this is so important, SolidWorks has a very nice tool that allows you to do this. So back in SolidWorks, that tool is called Pack and Go. So you go to the File menu and choose Pack and Go. And that brings up a list of, okay, here's the assembly file that I just saved, and also this is all the parts that make up that assembly. They're all selected, and you can choose to either save those all into one folder, or what you want to do for your homework is save all those to a zip file so that you have one file to upload to the Dropbox. So you save it to a zip file, click Save, it compresses everything, and that has now created this myrover.zip. If I open that folder, you'll see that contains the assembly file and also all of the parts that go into the assembly. And you can see it's more than just the original parts I downloaded. See, here's the ARM 1 and ARM 2 that I downloaded. Notice here is the mirror ARM 1 and mirror ARM 2. Those are the new part files that SolidWorks created when I did that opposite hand version. Okay? If you submit this zip file for your homework, everything is good. We can open your assembly and grade everything we need to. Now, just to really drive this point home, because this is a mistake that a few people make every semester, and then they get upset when they get a 0 on their homework. I've copied an assembly file from another computer without copying the parts. I've got this telescope.sldsm. I'm going to open this in SolidWorks to show you what happens. Just close the rover. Say open, telescope.solidassembly, open. Okay, SolidWorks brings up this error message and says it's unable to locate the file, base.solidpart. It can't find one of those assembly files. It wants me to either browse for the file. If I have the file on the computer, I can tell SolidWorks where to find it. But I don't have that file on the computer, so my only other option is to suppress that component. Now it goes to the next component in the assembly and asks me the same thing. Well, my only option is to go through and suppress all these components that it cannot find. And when I get that done, this is what I'm left with. And this is the full assembly right here. It's just blank. All the components are grayed out because they're all suppressed, and there's absolutely nothing that you can see for the assembly. Okay? So if I submitted this for my homework, how many points would I get for this assembly? 0. There's nothing here that can be graded. So please make sure you use the Pack and Go to create a zip file to submit your homework. All right. Any questions at all about the rover? Okay. Let's take a quick look at the wind turbine that you're going to create. Now, this is the other assembly you're going to create. I've given you the generator, the tower, and the hub parts. I've not given you the windmill blade. This is a part that you'll create yourself this week, because as we go forward with assemblies and drawings, we want to keep reinforcing those part building skills. And so one way to do that is to just have you build a new part each week. So you're going to make this part for your assembly. You'll use the sketch picture to bring in the correct profile. Use this sketch block to place that profile at the correct location. So there is a PDF of the window blade that gives you all the information you need to make this part. Okay. You're going to use some of those tools I showed you at the beginning of class to make the window blade part, and then the other files you can download from E2L. Here's the parts zip file. Download it to the desktop. Okay, so what's the first thing I should do with the zip files? Extract it. So right click, extract all. Okay, here's the extracted parts. I'm going to delete that zip file. I don't want that in the way. And now back in SolidWorks, I can start a new assembly. Let's browse and find what part do you think we should bring in first? Okay. Yeah, I would bring in the tower if I was making this assembly, although for purposes that you'll see in just a few minutes, I'm actually going to bring in the generator first. But I want to show you something about the tower. But I agree, you probably would bring in the tower first. And I'm going to insert a couple more components. I want the hub, put that there, and I want the blade. This is the part that you're going to make yourself, but I went ahead and made it just so we can go ahead and put this thing together in class. Now, when you look at this windmill blade, this actually is some very complex geometry. So you deserve a pat on the back for the fact that you can make models this complex with, you know, just, what, 5 weeks of class so far. You're really doing some very advanced stuff. But anyway, let's see. Let's go ahead and do a make. Let's put that edge of the hub to that edge of the generator, and let's put that edge of the blade to that edge of the hub. Okay, it went through the hub. So let's just flip that over. Remember the made alignments button right there. Let's flip it over. Okay, that's all good. Okay, so for the other two blades, what should we do?
Circular pattern?
Okay, we could copy with mates. That would be an option. We could just bring in more copies. We could control click and drag. Or here's another option, another shortcut to be aware of. In assemblies, just like in parts, you can create linear component patterns. You can create circular patterns. So let's do a circular pattern of the blades around the central axis of the hub. So choose, let's see, pattern axis will be that axis. The component of pattern will be the blade, and we can put in as many of those as we want. In this case, we only want 3. Okay. Now, one thing that's pretty cool about this, when you do the component pattern, those, again, are slave to one another. If you change the rotation of one, you can actually change the pitch of the entire wind turbine. I think that's pretty cool. But anyway, okay, so the only part we're missing here is the tower. And I want to take this opportunity to show you that you can actually create brand new parts right here in an assembly. So, now, first of all, why would you want to do that? What would be an advantage of creating a part when you're looking at the rest of this stuff on the screen?
You have stuff in dimension 2.
Okay. Yeah, in a nutshell, you can make your part so that you know that it fits, right? Suppose you're modeling a brake line in an F-150. You've got the whole assembly of the truck. If you're looking at the assembly of the truck, you can route that brake line so that you know it's going to clear all the other components it has to pass by. So one reason to do this is to just make sure it fits. Now, the disadvantage that comes with making a part in the assembly is you might end up making undesired references to the assembly or to other parts in the assembly. And this can create a very big headache, sometimes a nightmare in your part model. What I'm going to do is go to Insert Components, click the drop down, and say New Part. Okay, and I want to choose where I'm going to create that part. I'm just going to click on that bottom face of the generator. Okay, so in the model tree, the part that I'm just creating, which is randomly called Part 12, is blue. So even though I see the rest of the stuff on the screen, I'm really just working as if this is the only part that exists. Now, I would encourage you to always depress this button that says No External References. Because what this will do is prevent you from making those undesired references to other parts in your assembly. Okay? So, turn that button on, and let's go ahead and just, let's see, we're creating a sketch on that plane. Let's just take that surface and convert it. So you convert entities, click on that face, set that. Okay, now it gives me a warning. It says your selection is an external reference because of the current setting. That's the button I just clicked. The reference will be automatically broken. That's good. That's exactly what I want. I don't want my new part to be referenced to the generator because suppose in a couple weeks GE sends me a new copy of the generator model. I take this one out, put the new model in. Well, then the tower that I'm building is completely broken because it can't find the references that it needs. So we want to keep breaking those references so that my part is truly independent of everything else. I'm going to acknowledge that, and there were actually 2 references being made, so it popped up again. I'm going to say that. It's okay. Now, let's create a plane offset down here that I can loft to. So I'll go to Features, go to Reference Geometry. Let's see. All right, let's go to Features, Reference Geometry Plane. Let's make a plane that's offset from the bottom of the generator by a distance of, let's say, 120 feet. I think this is a pretty big model. Yeah. Okay. Again, it's giving me that same warning, but that's a good thing. I don't want to create those references. And on that plane, let's just sketch another, let's see, select plane. On that plane I just created, do normal to it, sketch a circle. Okay, and now we can just create the tower by lofting between those 2 sketches. So back on Features, a loft from that sketch to that. That looks okay. Okay, so there's the tower. Now, once you're done making this part, this new part in your assembly, click this button and that returns you back to the higher level assembly. Just click that button, you'll notice stuff is no longer blue over here, and all the other stuff in my assembly is back to gray. So now I'm back at the assembly mode. Now, let's go ahead and save this. And notice that part 12, that's the tower I just made. SolidWorks is telling me you've got to save that because that part hasn't been saved at all yet. Say save all. And I'm going to call this one, save it to the desktop and call it my windmill. Click save. Okay, now I get this long message again. There are parts that have features defined in the context of Assembly 1. Okay, it's just again telling me about that issue with the external references. Do I want those external references or do I not want those external references? Just click OK there. The important thing is here, save that power part externally. Make sure you change this to save externally. That way it won't create those references back to the original geometry. So say OK. Okay, so now I have saved my windmill solid assembly. What do I need to do in order to turn this in? Create a zip file using Pack and Go. So go to File, Pack and Go. Everything is selected, including part 12, which was the tower I just created. And I want to save it to a zip file. Click Save. And here is the zip file, which I could now upload to D2L. It's got my assembly and all the parts of my assembly. Okay, so any questions about that? Okay, a couple closing remarks here. First of all, when you create makes, think about what you're creating and try to avoid creating a bunch of extra, unnecessary, or redundant makes. Okay, keep your model simple. If you create redundant makes, SolidWorks is fine with that. It will not give you an error message, but it just makes your model more complicated and more difficult to debug. Because like with some of these models where you should have motion in the final assembly, sometimes people will get their model all put together and then it's all locked up and they can't figure out why it won't move. Well, it's because of an extra make somewhere. If you've got 75 makes, that's a lot harder to debug than if you only have 10 makes. And if 10 makes could get the job done, that's the better way to go. How many of you have taken Engineering 1412? Programming class, did you talk in there about making your programs elegant or efficient? Like if you can create a for loop that contains 3 lines of code, that's better than writing out 50 lines of code to do the same thing, right? It's the same way in SolidWorks. Your assembly is better if it's got 10 makes than if it has 50 makes to do the same thing. So keep things simple. The other thing is, when you download the parts from D2L, make sure you unzip that file to the extract all. Don't work directly with the zip parts. And finally, most importantly, make sure you use Pack and Go to create the file that you submit for your home. All right. So, if you have any questions,
I almost woke you up. I thought you